Hey guys, so today we're going to talk about one of the more complicated derivative rules, and that's the chain rule. This is a rule that you're going to see throughout your college career and throughout calculus. If you're in high school, A, B, and BC, you'll have to use this a lot, so it's really important to understand this, and it's also pretty tough to understand, so that's what I'm hoping this video will help. And we're going to talk about when to use it and how to use it. So when to use it. We use the chain rule when we're differentiating between a composition of functions. What this means if we're differentiating a function that kind of has a clear outside and then an inside function. So let's just go through some examples and determine if we need the chain rule. And you're going to notice some trends. The first one, 2x plus 5. Well, I'm assuming you already know the power rule and the product rule and the quotient rule. And this one we can see, well, there's nothing different about this one. We can just use the power rule. So that means no chain rule. So we can cross this one out. We would not have to do it there. But this one, we have 7x squared plus 7x all raised to the third. We could think of this as having an outside and an inside. We could think of this whole thing, just the power of 3 is the outside function. So it's something like x cubed would be the outside function, and this whole thing would be considered the inside function. And that is the type of case where you would need the chain rule. So yes, this takes the chain rule. And let's look at this one. We've just got x plus 5 to the 6th. And here again, I want you to notice that we have this inside and then we have a power. And that means that we're going to use the chain rule. If we have a whole function, and this could be a function, we could have f of x equals x plus 5, all raised to the 6th. That is the chain rule. The outer function in this case would be x to the 6th, the inside x plus 5. And now let's take a look at this final one. We've got x to the 6th plus 10x squared. Does this take the chain rule? Well, let's think. Are we differentiating a composition of functions? No, we're just differentiating one. We could just use the power rule like normal and get 6x to the 5th plus 20x, and that would be it. This does not require the chain rule. Okay, so now we talked about when to use it. Now we need to figure out how to use it. And what I like to call it is the outside-inside rule, because if you call it that, you kind of instantly know what to do. Whereas the chain rule, it's kind of confusing. Alright, so outside-inside rule. What it says is you take the derivative of the outside function, leaving the inside alone, and you multiply that by the derivative of the inside function, and that's it. That's how you take the derivative. So, and as we go through examples, we're going to label what the outside function is and what the inside function is. And what I always struggled with is, how do I know what the outside function is? And the outside function is always what you would do last if you were evaluating. So it's the final step in evaluating the function. That would be your outside function. So let's take a look. We've got f of x equals 7x squared plus 7x all raised to the third. And now we know that this requires a chain rule, so we're going to label our outside function and our inside function. Well, our outside function can just be seen as this exponent, so we can just say it's x to the third, and x is going to be short for this whole thing. And then the inside function, well, that's just going to be the 7x squared plus 7x. And the way I know that the x cubed is the outside function is because if I was evaluating, what I would do is I would solve for what is in the inside first, and then I would raise that whole thing to the third. Again, notice that that's the last step we do, so that makes it that outside function in the chain rule. Okay, so now let's get back to our rule. It says derivative of the outside function, leaving the inside alone. So let's do that right here. Derivative of the outside function of x cubed is just going to be 3x squared. Remember, like we said, we shorthanded this whole function right here by saying x, so we need to get back to that, and that's when we say leave the inside function alone. We get 3 times 7x squared plus 7x, and that whole thing raised to the second power. That is what it means by leave the inside function alone. We kind of just substitute it back in there. We don't change it or anything. We just substitute it. Then we multiply this by, well, let's see what it says. It says derivative of the inside function. Well, our inside function is the 7x squared plus 7x. Let's take the derivative of that. We're going to get 14x plus 7, just using our power rule. So 14x plus 7. And this equals f prime of x, and that's what we've done. We've figured out the derivative. We could simplify it, of course, a little bit. I'll do that here. I'll get f prime of x equals, well, I'm going to multiply the 3 by the 14x plus 7. I'll get 42x plus 21, still multiplied by 7x squared plus 7x, all raised to the second power. And that would be about as simple as I would want to go here, and that's the derivative. So let's do another example like that really quick. Let's say f of x equals, well, let's say 3x squared plus 10x plus 9, and let's raise it to the 7th power. Again, let's try to do this one without labeling our outside and inside. So first step is to bring this to the front. So we're going to get 7, well, I'll label this f prime of x, the derivative. We're going to bring this 7 to the front because that is the outside function, is x to the 7th. 7, and remember we leave the entire inside the same, so it's 3x squared plus 10x plus 9. Then it's all raised to the n minus 1, the 7 minus 1, so that's going to be raised to the 6th. And we're going to multiply that by the derivative of the inside, and this is our inside. Using the power rule, we can quickly get the derivative to be 6x plus 10. We could do a little simplification and get f prime of x equals, well, it's going to be 7 times 6x plus 10, which is 42x plus 70, multiplied by 3x squared plus 10x plus 9, all raised to the 6th power, and that would be our derivative. And you'll get the hang of this as you see more and more problems, and I'll have a lot more videos with just examples. But this video is just about explaining when and how to use it, so I hope this made sense. And now let's go on to another type where we're going to have a trig function. And now, I know this can be confusing, but the same concept applies. So we still have to label. For this one, we want to label our outside and inside just because it's our first time seeing it like this. And how do we know? Well, the outside is always what we would do last if we were evaluating. So if I was evaluating this function, I would figure out what's inside this parentheses, and then I would find cosine of that number. So the last thing I do would be cosine of x. So that's going to be our outside function. And inside is whatever I would do before that, which is evaluate the 4x squared plus 5 and get a number for that. Then remember, the chain rule says we take the derivative of the outside and we leave the inside the same. Okay. Well, derivative of cosine, that's a negative sine, so f prime of x equals negative sine of, and then it says leave the inside function alone. So instead of saying x, I'm going to say 4x squared plus 5, because that's what my inside function is. Then I'm going to multiply by the derivative of the inside function using the power rule. I can do 2 times 4 is 8x is the derivative of that. And using a little bit of simplification, I can say f prime of x, or just rewriting, I guess, is negative 8x sine of 4x squared plus 5. And that would be my derivative. And now let's quickly do another example just to make sure we understand it, because you'll definitely see a lot with trig as you go through calculus. So let's do 3x cubed plus 2x. Sine of 3x cubed plus 2x. Okay. Now I know, well, whenever I have trig, my outside function is always the trig function, and my inside is always what is inside, what I'm evaluating of the trig function. So that's going to be the inside function. And so first, what I do is I take the derivative of the outside. Okay, well, derivative of sine is cosine, so I'm going to get cosine. Then, well, what goes inside? I leave the inside function alone. So cosine of 3x squared plus 2x. And then what's my last step? Multiply by the derivative of the inside. Is, well, 3x cubed plus 2x. Take that derivative, we'll get 9x squared plus 2. So my final answer would be that right there. The derivative of sine 3x squared plus 2x is cosine of 3x squared plus 2x times 9x squared plus 2. And then for my final example, I want to do a bit of a different one. It's kind of a challenge here. We've got f of x equals e to the 7x squared plus 2x minus 1. And again, let's think hard about this. We've got to find our outside function and our inside. Outside, inside. And whatever that means is that what do we do first and what do we do last? The outside function is always what we do last, and if I'm going to solve this, what I would figure out is I would figure out what is up here, the value, and then I would say e to that value. So e to the x is my outside function. My inside function then is what I would do before that, which is evaluate what 7x squared plus 2x minus 1 is. So that's my inside. Then again, the same process for the chain rule applies here. Take the derivative of the outside, leaving the inside alone. That's the start. So f prime of x equals the derivative of e to the x, which is just e to the x. But remember, instead of x, we put our original function. So e to the 7x squared plus 2x minus 1. Not much change there. But then be careful, we still have to multiply by the derivative of the inside function, which is 7x squared plus 2x minus 1. So it's going to be multiplied by 14x plus 2, because that's the derivative of that function. So that's what we would end up with, and that would be our derivative. And that's it for the introduction to the chain rule. I'll have a lot more example videos, and I hope this made sense. I hope you understand when to use it, and then the basics of how to use it. The best thing to do is just to practice. Thanks for watching, guys. Let me know if you have any questions.